So what we did yesterday to today should be almost exactly the same. There should be very little changes. So as long as you're feeling comfortable with evaluating functions, function tables is just evaluating functions multiple times. For our piece of knowledge for today, in Taiwan, getting hit by a firework is supposed to give you good luck. So I don't want to go to Taiwan on, July the 4th. That'd be a pretty tough time. So once again, if you're dealing with ordered pairs, remember that the x always comes first in the ordered pair. And remember that f of x and y mean the same thing. So in this equation, we're actually going to change this to say y equals 2x plus 1. And I give you a table here, and this is the table that I like to create. I usually go from -2 to 2 on my table because it's the easiest table that you can possibly make. Starting a table at 0 and going to 4 is okay, but it will give you a much worse picture as you get to more difficult problems. So I recommend always making this table if possible. So what we do here is we just simply evaluate this function for each of these 5 spots. So it's like we're doing 5 problems. So in this one, y equals 2 times -2 plus 1. Well, 2 times -2, that's -4, plus 1 is -3. Therefore, this is the ordered pair, -2, comma, -3. For this next one here, I do y equals 2 times -1 plus 1. Well, that's -2 plus 1. That's -1. So it's the ordered pair, -1, comma, -1. Then for 0, I do y equals 2 times 0 plus 1, which is 0 plus 1 is 1. And it's also the ordered pair, blah, blah, blah. Now, I hope you see a pattern being created in this table. We're going up to, and if we've done this right, this pattern will continue. Now, if you don't trust the pattern philosophy, you can do this method for all of them in there as well and create your table that way. All right, but all you're doing here is we're creating this table by evaluating this function multiple times. Once again, important to remember that we change this f of x into a y before we start to give us an icon. So this says when x is -2 in this function, y equals -3. When this function is -1 for x, y equals -1, and so on and so forth. All right, this could go on infinitely in either direction. We could figure out, what x was 5 million. We could figure out what y would be in that same thing. Also, -5 million. We're just doing a very small sample size for the table. So for this one, it's the same idea. Now, what's important about this table is that I didn't do my -2, -1 system. And so this is not consistent. So we can't do our shortcut on this one. So once again, we're going to change this into y equals x over 4 minus 1. So I do y equals -4 divided by 4 minus 1. Well, this is -1 minus 1, which is -2. It's right there. For the next one, we can do 0 divided by 4 minus 1. 0 divided by 4 is 0. 0 minus 1 is -1. And now, once again, because we don't have a consistent table, we can't do the shortcut like we'd like to do. So we have to do 2 divided by 4 minus 1. Well, 2 divided by 4, that's 1/2. 1/2 minus 1 whole will be -1/2. And finally, 4 divided by 4 minus 1, well, that's 1 minus 1 is 0. Now, this is why I like my table, -2, -1, 0, 1, and 2, because it gives us a consistent pattern that we can see. For this, there's really not a pattern that exists, at least from the numbers that we chose. But we can still solve it the other way by just plugging in each x and figuring out each y. Okay, final example. This should be a negative, but my handwriting apparently is atrocious. I'd like you to try this one on your own and see what you get. For this one, I'll do the first couple and then do the table from there. It goes -3 times -2 minus 2. Well, that's 6 minus 2. This is a positive 4. Then we do -3 times -1 minus 2. This is 3 minus 2. That is 1. -3 times 0 is 0. 0 minus 2, that's -2. And now we have a pattern, -3, -3, -3, -3. And there is your table. Okay? If you have questions on any of this, make sure you let me know, because the next 3 or 4 sections are all going to just build on the topic that we've been working on here.